Okay, period 7A, welcome back. This is where we left off on Thursday the 12th. We were talking about a youthful stream, and we were looking at where in a youthful stream does the water move the fastest. So this is my aerial view. So if I was flying over top my youthful stream, it's a straightaway. It's moving fastest in the center. Because on the side where I have my banks, I have friction. Remember, friction slows things down. If I was looking at vertical, so I cut the stream so I can see the actual underneath the water, it would be moving fastest just underneath the surface of the water. Because at the top of the water, I have fluid friction. Friction between the air and the water itself. So just below the surface, it would be moving the fastest. I'm going to do a couple little drawings for you. So if I was looking at my channel shape, my straightaway, it's moving quickest at the center. So that means I'm eroding most in the middle. So this area, the blue area, would be my water. This area would be my sediments. So my water is moving the fastest just below the surface in the middle. So my channel shape is a V. If I'm looking at my mature stream, I have my meander. My meander, my curve, because of inertia. Remember, inertia is the resistance to change in motion. It wants to keep going that direction. So because of that, it actually moves the fastest on the outside. So since it's moving the fastest on the outside of the meander, that means it's eroding more. The greater the velocity, the more it can erode. The greater the velocity, not only more material will erode, but also the larger size particles that will erode. The inside of the meander is going slower. Because it's going slower, it can't carry that sediment, so it's going to deposit it. So if I was looking at, this is youth. If I was looking at mature, and I name this A and this B, A is the outside of the meander, it's moving faster, it's going to erode, it's going to be deeper. B is not going as fast, so it's going to deposit. So this would be my water again, and this would be my sediments. So my inside, I'm depositing, so the water is shallow. Outside, the water's moving faster, so it's eroding, so it's deeper. So this is my channel shape. Outside the meander, deeper, inside, shallow. That's mature. That is also true for old age. Remember, youth, V shape. Unfortunately, it doesn't keep it. Alright. So if I'm looking here, rejuvenated. So if I'm looking at a rejuvenated stream or river, that means it's got re-energized. In order to get re-energized, I've either increased the slope or the volume of the water, or both. One way to also do it is forming an oxbow lake. Oxbow lake, I need an extreme meandering. If I look at this diagram of a meandering stream, remember, the outside of the meander, it's moving faster. It's going to a road. This is an outside. Whoops. So this is an outside. This is an inside. Outside, inside. Outside, inside. So I got two outsides. They're going to row towards each other. Eventually, they're going to connect. When they connect, they actually straighten this lake, straighten this river or stream out. It's going to cut this off, and this is going to become eventually my Oxbow Lake. No longer will it be connected to this river. Its only source of water will be from the groundwater that feeds it. So here's my diagram. Here's my meandering stream. Outside, eroding, outside eroding. What happens is they connect, and you see how the river straightens itself out or it gets rejuvenated. With my stream, it can only downcut as far as the base of the river or stream is going to flow into or empty into. If my stream's going to empty into the ocean, it can only cut down to sea level. Now, reminder, as my velocity decreases, I can't carry those larger particles. I can't carry as much, so I start depositing. That is going to greatly slow down when my river enters that quiet body of water, be it a lake or be it an ocean. I'm going to form my delta. Now, the size or the shape of the delta is going to depend on, all right, how much sediments do you have? Do you have waves? What's the depth of that area? If I look at the end of the Mississippi is a bird shape or bird foot delta. We looked at the end of the Nile. The Nile is more of a fan-shaped delta. It all depends on the depth. I need you going back. 8th grade science. Potential energy. Remember, potential energy stored. Weight times height. Kinetic energy. Energy of motion. It's got to be moving. Half the mass times the velocity squared. If I'm going to draw my stream, I'm going to draw it from a side view. Here's the head of my stream. I'm going to say, here's my mouth. And this is where it's flowing into. Potential, weight times height. So where would it have the greatest potential energy? Well, the weight's not going to change, but the height is. So here at the head is where my potential is greatest. All right, what's going to happen is, as I leave the head, my potential energy is going to turn into kinetic energy. Kinetic, when is it moving the fastest? Is when it has the greatest kinetic. Usually with this one, I'm looking at a steeper slope. The steeper the slope, the faster it moves. When I get towards my mouth of my stream, or I get into a flatter slope, my velocity decreases. My velocity decreases, my kinetic energy decreases. What happens is that kinetic energy is moving into potential. So as I get to the mouth, kinetic energy is going to potential. That's when you start depositing sediments. right, we need to talk graded beds. With my velocity changing, some of it has to do with the volume. So if I go to the same stream month after month, when I have that snow melts at our normal precipitation, usually early spring, my volume is greater. So my volume greater, I'm actually moving. I have a higher velocity, so I'm moving larger particles. As my year goes from spring to summer, my temperature increases. As my temperature increases, my water gets evaporated. So I have less water, less volume. So that's going to slow the velocity of the stream down. So I can't move those larger particles. So I only can move smaller particles. Because of that, I'm going to get what they call graded beds. Here's an example of a graded bed. It's organized, this one, by size. Larger particles, early spring. Snow melt, regular precipitation. As my temperature increases, my volume decreases, smaller particles. So what I'm doing is I'm showing you how things change throughout the year. So here's one bed. All of a sudden I increase the velocity again, bigger particles, smaller, smaller, smaller. So the graded bed is organizing them by 3 different ways. Vertically, by size, largest on the bottom, progressively smaller. By shape, because if you take a crumpled piece of paper and you take a flat piece of paper and you drop them simultaneously, you'll find that the rounded one falls faster than the flat one, because the flat one has more surface area for buoyancy. The round one has less surface area, so it drops quicker. So rounded particles will fall or deposit before flatter particles. The other one is density. The more dense it is, the quicker it's going to deposit. So graded bed is vertically sorted by either shape, size, or density. Horizontal sorting, this has to go with how you deposit as you enter into that body of water, forming your delta. Same thing. The larger, more dense, rounder ones are going to get deposited first, and then the smaller, less dense, or flatter ones are going to get deposited last. So if I look here, here's the mouth of my stream flowing into my water. Pebbles are larger. If you can't remember that, you guys have a reference table. Page 6. My pebbles are larger. They're going to deposit first. Sand, silt, clay. Now, there's a thing called colloids. Colloids are permanently suspended unless you start playing with the concentration. Then they'll settle out. That's how we're going to get our limestone. That's going to precipitate further out. So this one is all organized by size. You could do the same thing about round versus flat, or most dense first to least dense. I hope this helps explain the notes. The notes are going to be, as you guys already have, they're already online, but I hope this explains it. I hope this helps you go through the videos from a couple weeks ago of the stream erosion. They might make a little more sense now. Also might help you with your next lab. All right, if you have questions, make sure you contact me. Email me. Thank you. Hope you're all well. Goodbye.